Welcome, future scientists. You've just entered the world of 10th class science.
Hi students! If you are new to this channel, please like, share and subscribe.
Hello everyone, welcome back to our learning podcast. Today we are diving into a topic that literally lights your world, that is electricity. To guide us, we have our guest, Miss Kavya. Welcome, Miss Kavya.
Thank you, Miss Reshma. So, electricity, it is not only a lesson or a topic that is printed in our textbook, right? It is a reason why our bulb glows, fan runs, and even this podcast is reaching to so many of our audience, right?
Yes, ma'am. So let's begin.
Yes, ma'am, sure, let's begin.
Then what is this thing called electric current?
So, imagine electric current as a flow of water.
Yes, ma'am.
What happens there? The water flows through a pipe.
Yes.
In the actual sense, water molecules are flowing. Okay.
Yes.
So here, if we relate this to electric current is nothing but the flow of electric charges. That too in a conductor. We have formula to calculate this electric current. That is,
Yes.
I is equals to Q upon T, where I stands for current, Q stands for charge, and T stands for time.
Yes, ma'am.
Okay. So this electric current is always measured in terms of ampere only.
Okay. Electric current is nothing but flow of charge.
Yes, exactly.
Now, what do you mean by electric circuit?
So electric circuit is nothing but let us imagine it is a closed loop of pipes.
Yes, ma'am.
If the loop is closed, we can pass the water.
Water.
If the loop is not closed or open, so water can't flow easily.
Yes, ma'am.
Likewise, in the electric circuits, it has battery, bulb, connectors, switch, ammeter, voltmeter, and all. If that circuit is closed, then only electric current can be passed through it. If the electric circuit is not closed or open, or if there is any breakage, means so what happens? The electric current won't flow properly.
Okay, ma'am. Until now, we said about electric current and the electric circuit.
Yes.
Now, question arises: what do you mean by that? Electric potential and potential difference.
Oh.
It is confusing many students.
Yes. Electric potential is nothing but imagine rooftop tank.
Yes,
Okay. The higher the tank, the more the potential energy of the water.
Yes.
Likewise, so electric potential means it is the energy. Okay, it is the energy required to bring 1 unit of charge through a conductor. Potential difference means water flowing from overhead tank to lower to the ground.
Yes, ma'am.
There in the overhead tank, there is more potential of water, but here there is less potential. Even in the if we relate this to electric potential means potential difference means positive terminal have high potential, negative terminal has low potential.
Yes, ma'am.
So a unit of charge coming from one point and reaching to another point. So that is a difference. Means higher to lower.
Yes, ma'am.
Okay. So that is what potential difference. We have one equation to calculate potential difference. That is V is equals to W upon Q, where V stands for potential difference, W stands for work done, Q stands for charge. Okay. So always we'll be calculating this potential difference in terms of volts only.
Okay. So, volt is like a water pressure of electricity.
Exactly, ma'am.
Yes, ma'am. While you are explaining electric circuit, you said about battery, ammeter, voltmeter.
Yeah.
Is it necessary to remember symbols instead of diagram?
Yes, ma'am. It is necessary to remember symbols, and these symbols make it quicker to understand.
Yes, ma'am.
Okay. See, instead of using the words crying, laughing, just use the emoji.
Yes,
It
ma'am.
is so much effective,
Easy.
as well as it is easy to remember. So likewise, instead of drawing old battery, bulb and connectors in the circuit diagrams, just use the symbols. So which makes it easier to understand. Again, it is quicker to remember also.
Okay, ma'am. Let's move to next topic.
Yes, ma'am.
What do you mean by resistance? Can you tell in simple way?
So resistance is nothing but it opposes the flow of electric charges.
Yes,
Or
ma'am.
it opposes the flow of electric current. Okay. So this is what resistance. So it is an opposing force.
Yes, ma'am.
This resistance is measured in terms of ohms.
Yes, ma'am.
Okay. So this resistance also depends upon certain factors. Let me clarify one by one. Imagine you're drinking a milkshake with a longer straw.
Yes, ma'am.
Okay, what happens then? We can't easily get that
Yes.
milkshake, right? So there the opposing force is more. The flow of milkshake is less. So likewise, if the length of the conductor is more, then the electric current can not pass that easily
Yes.
because it has more opposing
More
force.
opposing force.
So if we drink that milkshake with the help of straw, which has more area, so then what happens? We can easily get that.
Yes, ma'am.
So likewise, if the conductor has more area, means we can pass electric current easily. More electric current is also flow through it. So, but opposing force is less if there is a more area.
Yes, ma'am.
Again, this resistance also depends upon the material of the conductor. That is rope. Okay, means which type of material we are using. What is the resistivity of that material? If we are using conductors, we can pass current easily. Okay, there the resistance is low. If we are using insulators like wood and all, what happens? They have more resistance to the flow of electric current. So
Yes.
they can't conduct electricity. Okay, so that is why it also depends upon the material, type of material we are using.
Yes, ma'am.
Again, our last factor is temperature. If the temperature is increased, automatically the resistance will also get increased.
Yes, ma'am.
Okay, so like honey flowing slowly in a warm place.
Oh, that's a tasty example.
Yes, ma'am.
As you said, resistance is nothing but opposing force.
Yeah.
Now, what happens if we connect these resistors together?
So there are two cases
Yes,
to
ma'am.
connect these resistors. One is in series, another is one is parallel. Okay.
Yes, ma'am.
So in series connection, so what happens? It is head-to-head connection.
Yes.
Like a person, people standing in a line to enter a door. Their head-to-head connection is nothing but the series connection.
Series connection.
To know the current flowing or resistance in the series connection means, so we are using one equation, that is R equivalent is equals to R1 plus R2 plus R3 and so on.
Yes, ma'am.
So always current will be same in resistance that are connected in series. So once it come to parallel, here, so the water is supplied through only one tank, okay, to all the pipes that are present in a home. So parallel connection is the pipes are connected to each rooms, okay. Like one pipe will be connected to sink, another pipe will be connected to the washing machine.
Yes.
So this sink needs less amount of water, means less current. That washing machine need more amount of water, means more current.
Yes, ma'am.
So if we connect series in parallel, resistors in parallel connection, so that can control the amount of current that is going to the appliances. Okay. If we connect series in the home, so what happens means same amount of current is flown throughout.
Yes, ma'am.
Then the small bulbs they may get damaged due to
Yes.
high current. Okay, that is why we are using parallel connection. Again, always here potential difference is same, that is voltage.
Yes, ma'am.
Current will be varying.
Yes, nothing but in home appliances use parallel connection.
Yes, exactly.
So they get same amount of voltage.
Voltage, yes.
Yes, ma'am. Next, we'll move to our next topic.
Yes, ma'am.
What do you mean by heating effect?
So rub your palms together.
Yes.
They get heated up due to friction.
Yes.
Okay. Here also in conductors, electrons will move opposing the force of the resistance force. Means they are opposing the force. Means they both are clashing together.
Yes.
Okay. There the electrons are moving through the resistance or some opposing force. Then they get friction and then they get heated up.
Yes, ma'am.
Okay. So this is what we call heating effect of electric current.
Then where do we use this effect?
Everywhere it is used, ma'am.
Yes, ma'am.
Like in a bulb, okay. This bulb contains tungsten filament inside it. Until and unless that tungsten filament gets heated up, the bulb won't glow.
Yes, ma'am.
Okay, so the tungsten filament should be heated up to glow the bulb. Even in iron, toasters, and heaters, okay, heaters. So what are heaters? So here there is a one thing that is nichrome wire, which is an alloy. Okay, once that gets heated up, then only we can use those appliances.
Yes, ma'am.
Again, fuse also works on this principle, that is heating effect of electric currents. Here, fuse, which has a material or a metal or an alloy. What happens if the high current is flown through it, passed through it, so that material or metal will get melted, which won't further pass that high current to all the home appliances.
Okay,
So
ma'am.
it prevents the any damages. Yes.
Yes, ma'am. So finally come to our last topic.
Yes, ma'am.
What do you mean by power?
Power means how fast electrical energy is used.
Yes, ma'am.
We have three equations to calculate this power. Power means P is equals to V square upon R. P is equals to V upon V into I. Again, P is equal to I square into R. So
Yes, ma'am.
these are three equations. Always power is calculated in terms of watts.
Yes, ma'am. If my bill says it is 50 unit, nothing but 50 kilowatt hour.
Yes, exactly. See, these current bills will be measured in like this only, kilowatt hour.
Okay, ma'am.
Yes.
It was wonderful. Before we wind up, let me have a quick revision,
Yes.
like a rapid fire.
Yes, ma'am. Sure.
Yes, ma'am. Let us start.
Yes, ma'am. Let's start.
Yes, ma'am. Our first topic was electric current.
So, electric current is a flow of charge. Flow of charges in the conductor.
Yes.
So, we have formula that is I is equals to Q upon T. Again, current will be measured in terms of amperes.
Yes. Then it was electric circuit.
Yes, electric circuits means which consist of all the elements, that is battery, bulb, connectors, each and everything.
Yes,
The circuit is closed, then only electric current will pass. If the circuit is open, electric current won't pass.
Yes. Next it was electric potential and potential
Yes,
difference.
yes, it is the energy required to pass 1 unit of charge throughout the conductor. That is
Yes.
electric potential, energy required. Potential difference means work done to pass a unit charge from one terminal that has high potential to the another terminal which has low potential. Okay, we have formula to this, that is potential difference is equals to work done by charge. Okay,
Yes.
means work done to bring a unit charge. So the SI unit or the measure, how we will measure this potential difference means that is in terms of volts only.
Okay.
Yes.
Next it was circuit diagram.
Yes, circuit diagram. So instead of drawing whole battery, bulb,
Yes, ma'am.
so use symbols to
Symbols.
make it easier.
Yes, ma'am. Resistance.
Resistance is the opposing force to the flow of electrons or the flow of electric charges.
Yes, ma'am.
That is the opposing force. So resistance is measured in terms of ohms.
Yes, ma'am. Then what happens if we connect these resistors?
Okay.
to
So
different-
first of all, this resistance depends upon certain factors. That is
Yes, ma'am.
length, area, material we are using, again temperature.
Yes,
Okay.
ma'am.
So there are two cases to connect these resistors, as I told you. One is series and parallel. So series, the formula will be R equivalent is equals to R1 plus R2 plus R3 and so on.
Yes, ma'am.
Here current will be same. Again in parallel, 1 by R equivalent is equals to 1 by R1, 1 by R2, so on. Here the voltage will be same, but the current varies.
Yes, ma'am.
Hmm.
Next it was heating effect.
Yes, heating effect means that causes the friction, means flow of electrons, flow of electric charge through a resistance that creates a friction that causes the heating effect. So we can also call it as Joule's heating effect.
Yes, ma'am.
Joule's heating effect. Always heat is measured in terms of joules only.
Joules.
So we have formula for that also. That is H is equals to I square R into T.
Yes, ma'am.
Yes.
At last it was power.
Power. Okay. So power is how fast the electrical energy is consumed. We saw three equations for that. P is equals to VI, P is equal to I square into R, and P is equals to V square upon R.
Yes, ma'am.
Yes.
It was wonderful, ma'am.
Thank you, Ms.
It
Rishma.
will be helpful for students.
Exactly. So it will be helpful, like it will be like 1 minute revision during the exams and all. Okay.
Okay, ma'am.
Yes.
Thank you for joining us today, Miss Kavya.
Thank you, Ms. Rishma.
And for our listeners also, remember that electricity lights your world, but your knowledge lights your future. Until next time, stay bright. Thank you.
Thank you.